Following the end of the Civil War, William Harris Hardy, an attorney from Mississippi and a railroad pioneer, wanted to do something to help the economy in the South, which had been pretty much devastated. He felt it would be a great asset to have a railroad line connecting the bustling port of New Orleans directly with the industrial heartland of the country. But there was a 640 square mile, 40-mile long, and 25-mile wide problem: Lake Pontchartrain. Lake Pontchartrain, the largest lake in Louisiana, lay directly in his way. Undaunted, he continued to pursue his dream until finally in 1883, the New Orleans and Northeastern Railway line between Meridian, Mississippi and New Orleans, Louisiana was completed. One of the great engineering marvels of this line was the trestle crossing Lake Pontchartrain near Slidell, Louisiana. The original trestle was over 21 miles long and was constructed of timber. At the time of its construction, it was the longest railway bridge in the world. For over 100 years, the Lake Pontchartrain trestle has been the keystone in the line linking southern Mississippi and New Orleans with the industrialized North. Originally, 12 miles of untreated timber trestle approach was built over swampy ground on the south side of the lake, and an additional 3 miles of untreated trestle approach built on the north side. Only the main lake crossing, approximately 6 miles, was constructed of treated timber. Between 1887 and 1896, the untreated trestle was replaced with earth embankment. Southern Railway acquired control of the New Orleans and Northeastern Railway in December of 1916. And in 1982, as a result of consolidation of Norfolk and Western Railway and Southern Railway, this line became part of the Norfolk Southern system. Along with it came a lot of headaches. There are many problems inherent with maintaining the timber structure across such an expansive body of water. It crosses the lake in a north-south direction near the eastern edge of the lake. Westerly winds that cross the main body of water build up wind tides and wave action that batter the trestle. There is always the threat of fire, and hurricanes moving in from the Gulf of Mexico could cause major damage. Because of the extensive maintenance required for the timber construction and the susceptibility of the structure to damage, it became apparent that replacement with a different type of construction should be considered. When replacement of the North Drawbridge became imminent in the early 1980s, increased emphasis was placed on proceeding with development of a satisfactory design for the trestle replacement. Before selecting a design concept for the lake trestle, many types of construction were considered. Special emphasis was given to environmental concerns, effects of salt water on the building materials, service life, maintenance, and construction. As a result, reinforced concrete construction was decided upon. With special attention given to the mixed design and density, the concrete would hold up well in the hostile saltwater environment. The final design consisted of composite steel and pre-stressed concrete piles, supporting cast-in-place concrete caps. Under 8-foot wide and 30-foot long pre-stressed concrete box girders, placed 2 per span. Because work was to be performed under traffic, it quickly became apparent that a change in standard construction practices would be needed. Due to the large amount of materials going to and coming from the construction sites, and the considerable travel distance involved in clearing rail-mounted equipment for trains, working from the water would be necessary. Items of work normally done from the rail were moved to floating equipment anchored along the trestle. One of the most unusual pieces of floating equipment used in the project was a donut crane. This was a prototype by Schugert Manufacturing. It was a 100-ton American crane mounted in the center of a circular segmental flotation ring. The unit was self-propelled and was used for driving concrete pile and for setting the 30-ton span sections. Another innovative approach was the use of rail-mounted equipment, operating on short track built on floating work barges. The actual construction of the concrete trestle consisted of 4 primary operations. First, the steel pipe pile section of the composite steel and concrete pile was put in position, then driven 60 to 100 feet into the lake bed. This was done using a locomotive crane rigged with a pile hammer. Once the steel pile was driven, the crew cut it off, ready to receive the concrete section. Next, the concrete portion of the pile was added to the already driven pipe pile and attached using a compression ring coupling. Using the donut crane rigged with a pile hammer, the 35-foot-long concrete pile was driven to grade. This assured the steel section was well below the mud line and only the concrete pile was exposed to the highly corrosive salt water. After the concrete piles were driven, the capping crew began building the cast-in-place concrete caps. Prefabricated steel forms were used. Concrete was delivered to the site in regular concrete trucks loaded on flat cars. Concrete was poured into the forms, making caps that would support the span sections. Then the donut crane was re-rigged for the final operation, setting the spans. Working with the crane, the crew pulled the old drift pins. The stringers were pulled free, caps removed, and the old timber piles were removed from under the bridge. With just the welded rail still attached to the ties, the section next receives the new 2-piece pre-stressed concrete span. With the span set in place, the ballast was added, and everything checked to ensure proper track geometry. From its beginning in 1983 until its completion in 1996, the job of replacing the timber trestle across Lake Pontchartrain has been done by Norfolk Southern Bridge and Building Forces. These men are to be commended for their efforts. In the first year of construction, only 985 feet of trestle was built. At the completion of the project, they could build over 3,500 feet of trestle per year with minimal interruption to train operations. Cooperation and innovation are the 2 key elements that made this project successful. Cooperation from the Transportation Department for providing adequate work windows for the construction, and innovation on the part of the bridge engineering staff, field supervision, and labor for developing efficient work methods and labor-saving devices that facilitated the safe completion of this major project in an environment that at times was less than hospitable. The rebuilt Lake Pontchartrain trestle contains 997 spans and is a total length of 30,742 feet. Incorporated in the construction is 103 miles of steel and concrete piling and 180 million pounds of concrete components. Norfolk Southern's line serving the Crescent City now crosses the eastern end of Lake Pontchartrain on 5 3/4 miles of state-of-the-art concrete ballasted deck trestle. Truly, this structure represents Norfolk Southern's quality process working at its best.